Alright guys, we're moving on to Chapter 2, and Chapter 2 is all about solving equations. So we're starting with the simplest of equations, solving one-step equations in one variable. And you probably did this last year in pre-algebra. Okay, let's look at the getting ready box on page 81. So it says the diagram shows the amount of money that a player starts with in a video game. To be fair, each player should have the same amount of money. Now that's important. When they say each player should have the same amount of money, that's how you know you're going to need an equal sign. So what must be in the chest? How do you know? So if player 1 has to equal player 2. If we look and see what player 1 has, let me add all these up. It looks like we have a 10 plus 5, so that's plus another 5, 20, 22, 24, 26, 27, 28, 29, 30. I think I counted them right. If I added all of them up, so I got 30 for player 1. Now for player 2, they have 5, 6, 7, 8, 9, 10. They have $11, I guess, or whatever this would be in coins, plus they have some amount of money, oops, not times, plus they have some amount of money, jeez, why do I keep writing that? Plus they have some amount of money in the treasure chest. So to figure out how much money's in that chest, instead of putting a question mark, we'll make an equation, 30 equals 11 plus x. And if we solve this equation for 30, we'll figure out how much money is in the chest. And what we're going to be doing is, hopefully you remember this from last year, just subtract 11 from both sides. So x is going to equal 19. Okay, so there must be $19 or chips or whatever inside that chest. Okay, the vocabulary here, an equivalent equation. Again, this isn't something they're really ever going to ask you, but you need it for the rest of the chapter. They're just equations that have the same solution. So if I start you with this equation, x plus 4 equals 10. Now that's an equation. An equivalent equation, as long as I do the same thing to both sides. So let's say I still have x plus 4, and then I still have 10. If I add 5 onto both sides, these two equations are equivalent equations. If I start with x plus 4, and I still have equals 10, and I decide to subtract 7, as long as I do that from both sides, they're still equivalent equations. So that's all that is, equations that have the same solution. So these are the properties for addition and subtraction, properties of equality. It says for any real numbers a, b, and c. Okay, if you start with a equal to b, so let's say we start with x plus 3 is equal to 4. As long as I'm adding on the same number to both sides, it's still equal. So I can add on, I can do x plus 3 and I can add on 2 to that side, and as long as I add on 2 to the other side, that's allowed. That's a property. Now, I can't add on 2 to one side and not the other side, or I can't add on 2 to one side and 1 to the other side. And the same thing with subtraction. So if I have x plus 3 equals 4, I can also subtract the same number from both sides. So if I have x plus 3, I can subtract 5 from both sides as long as I do that from both sides. Now, hopefully you realize I probably shouldn't be subtracting 5 and subtracting 2. What I should be doing from this equation is subtracting 3 from both sides, but I'm just trying to show you an example. Okay, in order to solve an equation, you're going to hear me say a lot, we need to isolate a variable. So if this is our equation, x plus 5 equals 12. The variable is x. So in order to solve this, we need to isolate for the variable, and it needs to be x equals. So we just need to solve that for x. Now in order to do that, you need to use inverse operations. So the inverse operations, add and subtract. Those are inverse operations. Multiply and divide. That they undo each other. And also squaring, this is more for later on, and square rooting are inverse operations. We'll get to that in a couple chapters from now. But as long as you know that addition and subtraction are inverse operations and multiplication and divisions. I should really put arrows on both ends of this because they go either way. So problem 1, solving an equation using subtraction. I mean, this is pretty easy. If we have x plus 13 equals 27, in order to isolate the variable, we have to use the inverse operation. So if right here we have plus 13, the opposite of adding would be subtracting. So we subtract 13, and again, the property says you can do that as long as you do it to the same side. So 13 minus 13 would be 0. You don't really need to write x plus 0 because that's really just x. So we write x equals 27 minus 13 is 14. And it usually says check to make sure your answer is right. So if x equals 14 is a solution, we should be able to put that back into the equation and do 14 plus 13 and get 27 and check. So we did it right. So got it, number 1. What is the solution of y plus 2 equals negative 6? So y plus 2 equals negative 6. Because we're trying to solve for y, the operation we want to undo is plus 2. So the inverse operation would be to subtract 2. And 2 minus 2, that's going to be 0. So we're left with y equals, now 6 minus 2. If you're getting better with these integers, you can just realize that that's going to be negative 8. Or you can do 6. If you write it like this, 6 minus 2. That's really negative 6 plus negative 2, which is equal to negative 8. So our solution would be negative 8. That's why you really need to have these integer rules down. Alright, solving an equation using addition. So if we have the equation negative 7 equals b minus 3. Now for some reason people always want to do the operation that's over here on the left side, and they would want to add 7. But you don't want to add 7 because what you'll hear me say is 7's not the problem. It's the subtract 3 that's the problem. You're trying to solve for b. It doesn't matter if it's on the left side or the right side. So in order to get b by itself, we have to undo this subtract 3. So we need to add 3 to both sides. And so this really, what this is over here, is b plus a negative 3, right? So we just wrote it as subtraction. So a negative 3 plus a positive 3, that's going to cancel out, and that's just b. Okay, and then negative 7 plus 3 is going to be negative 4. So the solution is b equals negative 4. Okay, got it, number 2. So now, what's the solution of each equation, and when we want to check our answers? So if we have m minus 8 equals negative 14. Because we're subtracting 8, we want to add 8 to both sides. And we get m equals negative 6. Now, this part right here that says check your answer, that's just to make sure you did it right. So if we plug negative 6 back into the equation, negative 6 minus 8 equal negative 14, check. It is, because negative 6 minus 8 would be negative 14. Alright, and for part B, we have fractions, so we have 1/2 equals y minus 3 over 2. So if we're subtracting 3 over 2, we want to add 3 over 2 to both sides. Now, usually when I do fractions, I like to write them horizontally. So 1/2 plus 3 over 2. You already have a common denominator, which is 2, and 1 plus 3 would be 4. Now 4 over 2 just equals 2. So our answer is y equals 2. And if we plugged it back into the equation, is 2 minus, now think of like 3 over 2 as 1/2. So is 2 minus 1/2 equal to 1/2? We could change them to decimals. Yeah. Okay, we have the same thing for multiplication and division. So same thing for all real numbers a, b, and c. If you start out with something that's equal, if a equals b, as long as you multiply both numbers by the same same thing, it's still equal. And the same thing for division. I guess we could write this as A divided by C equals B divided by C. Now this is important. C can't equal 0 because remember, you can't divide by 0. So if we had some examples, I'm not going to show you the same examples in the book. I'm going to show you examples of when we're actually going to use this. So if we have, let's see, you can multiply both sides by the same number. So if we have x over 4 equals 2. In order to solve this, we need to multiply both sides by 4. So if I can multiply this side by 4, and I can multiply this side by 4. And then if A equals B, so we can divide both sides by the same number. So if I start with 4x equals 8, I need to divide both sides by 4, and that's how I solve the equation. So that's more of how you're actually going to use these properties. Problem 3, solving an equation using division. So this is the same thing. If we have 4x equals 6.4. Now remember, the goal is to isolate the variable and get x equals. So when we did addition and subtraction, the goal was to get x plus 0 because we didn't need to write the 0 part. Now we don't really want to get x plus 0 anymore, but what we want to get is 1 times x, because 1 times x is just going to be x. So you need to, here's your variable x. You need to think about what number you're going to divide by so that you have 1x. So if I divide both sides by 4, 4 divided by 4 equals 1. So I have 1x, and then 6.4 divided by 4 is equal to 1.6. Now, you don't really need to write 1 times x. You just need to write x equals 1.6. But that's what you're thinking here. Now I'm trying to get 1 times x, which would just be x. So, got it, number 3. Okay, if we have 10 equals 5x, you're trying to solve for x. So, right now you have 5 times x. The inverse operation of multiplication is division, so you divide both sides by 5. Now what we usually do is cross off 5 divided by 5 because that's going to be 1. So this side we're left with x, and this side we're left with 2. And if you want to check your solution, is 10 equal to 5 times 2? Yes. Okay, and if we have negative 3.2z equals 14, I hate writing z's because they look too much like 2's. You want to solve for z, so you want to divide both sides. Now, this is where it gets tricky. Do you divide by 3.2 or do you divide by negative 3.2? Remember, you need to get 1, not negative 1. If I divide by 3.2 on both sides, a negative divided by a positive is going to give me a negative. So you don't want to divide by 3.2, you want to divide by negative 3.2. So that a negative divided by a negative cancels out, and that's a positive. So I have z equals, and 14 divided by negative 3.2 is negative, because positive divided by a negative, 4.375. And we're going to use calculators from here on out. We're not going to have to go through the long division, but if you wanted to check it, is negative 3.2 times negative 4.375 equal to 14? I'm going to check it on my calculator right now to make sure I did it right. And yes, it's equal to 14. So we checked it. Okay, let's simplify one where we have to use multiplication. So if we have x divided by 4 equals negative 9. Now, this is division, x divided by 4. So to undo division, we need to use multiplication. So we need to multiply both sides by 4. Now, 4 divided by 4, right? You can kind of see how we have a 4 on the top and a 4 on the bottom. Those will cancel out, and we have x equals, now negative 9 times 4 is going to be negative 36. And if we wanted to check it, is negative 36 divided by 4 equal to negative 9? Yes. All right, got it, number 4. What's the solution of each equation? Check your answers. So for part A, we have 19 equals r divided by 3. You got to think the inverse operation of division is multiplication. So if I multiply both sides by 3, that will cancel out these 3's. And on this side, I still have r, which is what you're trying to do. You're trying to isolate the variable. And 19 times 3 is 57. So r equals 57. And if you want to check, is 19 equal to 57 divided by 3? 57 divided by 3? Yes. Okay, so we checked it. Let's see. Part B. Now, for these, when you put your answers in, make sure your answer isn't 57. Your answer is r equals 57. Okay, that's how I'm going to put it in the computer. So you have to make sure you don't just put in 57 because we're solving an equation. So your answer needs to be an equation. Okay, so make sure on any of the other got it's, if you didn't box around the whole thing that the variable equals the number, then make sure you go back and do that before you do the warm-up quiz. All right, part B. So we have x over negative 9 equals 8. Again, your goal is to get x, 1 times x. So think about if you're going to multiply by 9 or if you're going to multiply by negative 9. If I multiply by 9, 9 divided by negative 9 is still a negative. I have to multiply by negative 9 so that the negative and the negative cancel out. So I'm left with x equals negative 72. So that is your answer. X equals negative 72. And if you want to check, is negative 72 divided by 9 equal to 8? Yes. Divided by negative 9. Yes. Okay, this last part kind of, there's 2 different ways to do it. I'll show you. It's solving equations using reciprocal. So remember, reciprocal, like the reciprocal of 4 over 5 is 5 over 4. The reciprocal of 1 over 3 is 3 over 1. So here's your equation. 4 over 5m equals 28. Now, this is 4 over 5 times m. So the opposite of times is divide. So if I divide this by 4 over 5, I have to divide this by 4 over 5. Now, 4 over 5 divided by 4 over 5 will cancel out. That's easy. And remember when you divide by fractions, you have to do keep, switch, flip. So you have to change this into 28 times 5 over 4. And now, if you want to put the fraction in your calculator and do 28 times 5 over 4, like as a fraction you can. But what I would do here is I would do 28 times 5. And I would get that number. 28 times 5, that's equal to 140. And then I would take and I would divide it by 4. And that's equal to 35. Let me check that. 140 divided by 4 is equal to 35. Okay, so m is equal to 35. That's one way to do it. So let me box this. This is one way. I think that's a lot of work, multiplying and flipping around the fraction. So let me just show you how I would do it. If I have 4 over 5m equals 28. I'm going to do the exact same thing, but I don't have to worry about doing keep, switch, flip for the fraction. If I see here, I have 4 times m, but I also have a divide by 5. So I know the inverse operation of divide is multiply. So the first thing I'm going to get rid of is the 5. I'm going to multiply both sides by 5. That'll cancel out the 5's. So I still have 4m equals, now 28 times 5, that's 140. And then I take both sides and I divide it by 4, and I get m equals 35. So I still get the same answer, but I didn't have to worry about dividing by fractions. Okay, I'm pretty sure we have another one, so I'll show you that same thing again. This one, so what's the solution of 12 equals 3 over 4x? Okay, so, I mean, if you if you want to write it like this, 12 equals 3x over 4. Because 3 over 4x, it doesn't really matter if the x, the x goes with the top because technically it's x over 1, right? So it's 3 times x over 4 times 1. But even if you just leave it like this, that's fine. Now, to get rid of, here's the thing. You have to get rid of the divide by 4 first. You always want to get rid of the fraction part first. So in order to get rid of a divide by 4, I have to multiply by 4. So I'm going to multiply this side by 4, and I'm going to multiply this side by 4, so that the 4's cancel out. 12 times 4 is 48. So I have 48 equals 3x. You have to make sure that you still have the 3x. And then I'm going to divide both sides by 3 and get 16. So 16 equals x. Okay, if you wanted to, here's the multiplying by the reciprocal way. 12 equals 3 over 4x. So if you're multiplying by 3 over 4, you can divide both sides by 3 over 4. So divide this side by 3 over 4. And to me, that just creates too many lines. But what you have is 12 divided by 3 over 4, which you have to change into 12 times 4 over 3. And see how you're still timesing by 4 and then dividing by 3? I mean, I don't know. I just think it's easier, and that's something we can practice more tomorrow because you kind of have to do those kind of problems a couple times till you get really good at them. Alright, and last part we have this using a one-step equation as a model. So this chapter is going to have a lot of times where you're going to have to write an equation. So if you can kind of decide, like we're going to have one-step equation, two-step equations, multi-step equations. If you can figure out which kind of equation it is, it will help you write the equation. So this first one is a one-step equation. So we have toucans and blue and yellow macaws are both tropical birds. The length of an average toucan is about 2/3 the length of the average blue and yellow macaw. Toucans are about 24 inches long. What is the length of the average blue and yellow macaw? So they want you to relate the two different lengths. So it defines your variable at length. It says let L equal length of an average blue and yellow macaw. So length of L equals length of blue and yellow macaw. Okay, now it tells you that toucans are 24 inches long. So we have 24 inches. And it says the length of the average toucan is. So if this is the length of the average toucan is, which means equals, about 2/3 the length. 2/3 the length of the average blue and yellow macaw, which we said was L. Okay, so the length of the toucan is, the length of the toucan, 24, is equals 2/3 the length of the average length of the blue and yellow macaw, which stands for L. Okay. Now, if L stands for the length of the blue and yellow macaw, you can solve this equation to figure out the average length. So here's another one of those equations. If I write it a little neater over here, 2/3 L. Well, because I see this divide by 3, the first thing I'm going to do is multiply both sides by 3. And 24 times 3 is 72 equals, now the 3's cancel out, but I still have 2L, and then I have to divide both sides by 2, and 72 divided by 2 is 36. So, the average length of a blue and yellow macaw is about 36, and this is in inches. So 36 inches. Audit number 6. It says an online DVD rental company offers gift certificates that you can use to purchase rental plans. You have a gift certificate for $30. The plan you select costs $5 per month. How many months can you purchase with the gift certificate? So when you read that last part, how many months, if that's the question that you're trying to figure out, how many months, that's what your variable should be. So we're going to say M stands for months. Okay, so, and then you read the problem again. Well, the online DVD rental company offers gift certificates that you can use to purchase rental plans. Okay, you have a gift certificate for $30. So you have $30. The plan you select costs $5 per month. So it's $5 every month. So for 1 month it would be 5 months. For 1 month it would be $5. For 2 months it would be $10. So you're going to do 5 times the amount of months. Now, how many months can you purchase with the gift certificate? Well, you have to set them equal to each other. And then if you have 30 equals 5m, use inverse operations, divide both sides by 5, and you get 6 equals m. So now, because this was a word problem, you don't want to type 6 equals m in as your got-it answer. The question was how many months. So your answer is 6 months. Okay, it's a little different when it comes from a word problem. You just have to make sure you put a label on your answer. And that's it.